Today we are going to start the very first section of our last unit. In order to do that, we need to define a polyhedron. A polyhedron is a solid bounded by polygons. Now I'm just going to make a little side note here. Remember, polygons have no curved edges or no curves, and just make sure that it is also enclosed. Okay. All right, now a face. A face of a solid or of a polyhedron is an enclosed single region. It's one of the polygons, essentially. This is an enclosed single region, aka polygon. Now the bases is going to depend on the type of shape that you're looking at, but it's also just another face. And we'll go more into detail about what bases are. It really depends on the shape. Now an edge is the intersection of two faces. Okay, so let's go ahead and look over here at this shape and talk about the different pieces, and we'll just go ahead and label it off to the side. So this is a polyhedron because it's bounded by a bunch of rectangles or parallelograms. It is a rectangular prism. Faces. Now technically all of these are faces. However, this that I'm highlighting in red, for example, is an example of a base. Another base might be the one above it. It's got two parallel congruent bases. Now faces would be the rest of the polygons. So for example, I can do the front here in orange. That is an example of a base. Now technically bases are faces as well. Okay. The edge, which we just talked about, I'll go ahead and highlight in blue here. An edge is just an intersection of two faces. So for example, AD is an edge because it's where plane AEGD or face AEGD and face ABCD meet. So that's why it's called an edge. And then a vertice or a vertex is just one of the corner points where the faces meet. Oops. Okay, so let's go ahead now and talk about a cross section. A cross section is the intersection of a plane and a solid. So a cross section is the intersection of a plane with a solid. So an example of a cross section is in this picture here. I'm going to highlight it. If you take this plane and slice it through the sphere, the cross section is what I'm highlighting in blue here. It is, in this case, the cross-section of a plane and a sphere is a circle. Now, it doesn't always have to be that way. If I were to do a cross-section of, let's say, a cone, if I draw a cone and then I draw a plane slicing through it, its intersection would be a circle as well. It really depends on the surface itself. Okay? All right, now we are going to talk about prisms. So the definition of a prism, and this is very important, is that this is an enclosed solid, or actually let's just go ahead and call it a polyhedron. It's just faster. A polyhedron with two parallel and congruent bases. Those two words are imperative, parallel and congruent. So for example, let's go ahead and look at the hexagonal prism to the right, on the right here. Do you notice how what I'm shading in or kind of coloring in purple here is a hexagon? And it has a parallel congruent version of itself and an identical version right below it. So they are parallel and they are congruent. They're the same shape, same size. This is what we call a hexagonal prism, because we name prisms by their bases. So let's go ahead and jump over to the left now. This is probably one of the easier versions. Now the base does not always have to be what it's sitting on, but it can be. Now in this case, if I were to call this top portion a base, then I would also have, that was a really bad drawing, I would also have to call its parallel congruent face on the other edge also a base. This would be a rectangular prism. Now this last one, I'm actually going to do some erasing. So before you go writing down what I write here, you might want to wait and see what happens, because a lot of people mess up and make a mistake on this picture here. A lot of people try calling this the base. And I totally get why they're thinking that, because that's what this prism is sitting on. But if you try to envision a parallel congruent version, keyword being parallel, there is not a parallel version of that blue rectangle above it. There's not another rectangle chilling up here that's parallel to it floating above it, which is why that what I highlighted in blue there is absolutely not the base. Instead, in this case, the base is actually this triangle. So I always kind of envision these triangular prisms as a wedge of cheese, and in this case that kind of got kicked over. So this is a triangular prism, again because the triangles are the ones that have the parallel congruent bases. Now if we come back over to the rectangular prism here, you could have called the bases on the left and right. That's really dependent on the problem and what you want to do. The rectangular prism has freedom to choose. In these last two examples, we have no choice. The hexagons are the only parallel congruent pieces, and in this one here, the triangles are the only parallel congruent pieces. All right, so now time for our formulas. Lateral area formula is going to be LA equals capital P times H. Now, the other way is I often sometimes will do a subscript of a B, because this stands for perimeter of the base times the height. So I'm going to kind of put them in this box here. LA equals PH, or if you want to, P sub B times H. Okay? And then the total area, also sometimes known as surface area or TSA. It all means the same thing, all the same. You're going to take your lateral area and you're going to add in your two bases. So real quick, coming back up to look at this hexagonal prism. This prism has 1, 2, 3, 4, 5, 6 rectangular lateral faces, and then it has the two bases on top and bottom, so it has 8 total faces. So that's part of the reason why we can't have a more specific formula here, because it really depends on what kind of shape you're working with. So our total area is LA plus 2B. Now what does capital B stand for? This is really important. Capital B stands for area of the base. So let's go ahead and look at an example. Okay. In this first example problem, it says find the lateral area and the total surface area of the right triangular prism. The word right, they're just telling you that it's standing upright. That's essentially what they're trying to tell you with that word, right triangular prism. It has nothing to do with the actual triangle itself. It's just telling you that the triangle, the bases are parallel. So the bases here are the triangles. So the very first thing I do every single time is I start off by writing my formula. LA equals PH. What does pH mean? pH is the perimeter of the base. Okay, well then I tell myself, well, find the base, let's find the perimeter. Perimeter is the sum of all three sides. Well, in this case, I've got 5 and 13. I need that third side. You could choose to do the Pythagorean theorem, or you can know your triple. It's a 5, 12, 13. I'm not going to spend time in this video going through the Pythagorean theorem, but I can go ahead and set it up for you. 13 squared equals 5 squared plus x squared. If you need help with that, you just let us know and we'll help you in class. So I have 5 plus 13 plus 12. So my perimeter is 25, 30. Now I need to find the height. Well, the height is that segment that separates your bases. So in this case, the height is 8. So my lateral area is 30 times 8. So my lateral area is 240 feet squared, because remember this is area, so units are squared. Now total area, once again I write down my formula, TA equals LA plus 2B. Well, that's a nice reminder that I need to find out what the base is. The base in this case is a triangle. Well, the area of a triangle is 1/2 base times height. You have to be very careful in this section. Lowercase b and uppercase V are very different. That's why it is so important that you do a capital B on these formulas and not a lowercase b, so that when you have something like this, we don't get confused. So this is 1/2 base times height. Find the right angle. That will always give away where the base and the height are. So 12 times 5, which is 60, divided by 2 is 30. So now I have capital B to be 30. So my total area is going to be the LA, which is 240, plus 2 times my base, which is 30. So 30 times 2 is 60, plus 240 is 300 square feet. So that is just about finished with the notes. There are practice problems on the back, but we're going to go ahead and fill in the very first column, the very first row of your solids chart. So if you want to make sure to get that out, the very first solid is going to be a prism. And our lateral area formula, LA equals PH, or you can do PB. You can leave off the B, that's up to you. And then the total area is LA plus 2B, because there's two bases. We will come back to volume next week. So that is it. Go ahead and try the problems on the back of your note sheet, and we will touch base in class on Monday.